Elon Musk's XAI might be ready to disrupt the market, and NVIDIA is right in the crosshairs. While many are still focused on NVIDIA's monumental growth, Jensen Huang is sounding the alarm about the next big shakeup. So, what's really at stake for NVIDIA? And why does Huang believe that Musk's latest AI venture could leave the competition in the dust?
I'm Julie Hyman, host of Yahoo Finance's Market Domination, here with our tech editor, Dan Howley. NVIDIA has done it again, the chip giant blowing past analyst expectations in its strong fiscal first quarter. Data center revenue alone soaring by 427% year over year. And the company also gave another bullish sales forecast, which shows that AI spending momentum continues apace. On top of all that, the company also announced a 10-for-1 forward stock split and raised its dividend. Joining us now, NVIDIA founder and CEO Jensen Huang, fresh off the conference call. Jensen, welcome. Thank you so much for being with us.
I'm happy to be here. Nice to see you guys.
You too. I want to start with Blackwell, which is your next generation chip. It's shipping this year, you said on the call. You also said on the call, we will see a lot of Blackwell revenue this year. So if we're looking at about $28 billion in revenue in the current quarter, and Blackwell is a more expensive product than Hopper, the chip series out now, what does that imply about revenue in the fourth quarter and for the full year?
Well, it should be significant. Yeah, Blackwell, and as you know, we guide one quarter at a time. And but what I could tell you about Blackwell is this. This is a giant leap in AI, and it was designed for trillion parameter AI models. And this is, as you know, we're already at 2 trillion parameters. Model sizes are growing, about doubling every 6 months, and the amount of processing between the size of the model, the amount of data is growing 4 times. And so the ability for these data centers to keep up with these large models really depends on the technology that we bring to them. And so the Blackwell is designed also for incredibly fast inferencing. And inference used to be about recognition of things, but now inferencing, as you know, is about generation of information, generative AI. And so whenever you're talking to ChatGPT and it's generating information for you or drawing a picture for you or recognizing something and then drawing something for you, that generation is a brand new inferencing technology, is really, really complicated and requires a lot of performance. And so Blackwell is designed for large models, for generative AI, and we designed it to fit into any data center. And so it's air-cooled, liquid-cooled, x86, or this new revolutionary processor we designed called Grace Blackwell Superchip. And then, supports InfiniBand data centers like we used to, but we also now support a brand new type of data center, Ethernet. We're going to bring AI to Ethernet data centers. So the number of ways that you could deploy Blackwell is way, way higher than Hopper generation. So I'm excited about that.
I want to talk about the inferencing, Jensen. You know, some analysts have brought up the idea that as we move over towards inferencing from the training, that there may be some in-house companies, processors from companies, those made from Microsoft, Google, Amazon, may be more suited for the actual inferencing. I guess, how does that impact NVIDIA then?
Well, inferencing used to be easy. You know, when people started talking about inference, generative AI didn't exist. And now generative AI is of course, is about prediction, but it's about prediction of the next token or prediction of the next pixel or prediction of the next frame. And all of that is complicated. And generative AI is also used for understanding in order to generate the content properly, you have to understand the context and what is called memory. And so now the memory size is incredibly large, and you have to have context memory. You have to be able to generate the next token really, really fast. It takes a whole lot of tokens to make an image. It takes a ton of tokens to make a video, and it takes a lot of tokens to be able to reason about a particular task so that it can make a plan. And so the generative AI era really made inference 1,000,000 times more complicated. And as you know, the number of chips that were intended for inference kind of fell by the wayside, and now people are talking about building new chips. The versatility of NVIDIA's architecture makes it possible for people to continue to innovate and create these amazing new AIs. And then now Blackwell's coming.
Jensen Huang's message couldn't be clearer. AI is not just the future, it's the now. NVIDIA's explosive growth, particularly in the data center sector, speaks volumes about the accelerating demand for AI. But let's dig deeper here. The numbers alone are staggering. 427% growth in data center revenue. AI spending shows no sign of slowing down. And the company is even rewarding investors with a 10-for-1 stock split. This is a signal that AI is in the middle of a seismic shift, and NVIDIA is at the heart of it. When Huang talks about Blackwell, the upcoming chip that's poised to disrupt the AI space, he's talking about the foundation for the next era of AI. Blackwell is designed to handle the mammoth size of AI models that are doubling in size every 6 months. These are trillion-parameter powerhouses that require an entirely new level of infrastructure to run effectively. But here's the thing. This is NVIDIA rethinking the very structure of AI processing. Blackwell's design focuses not just on scaling performance, but on supporting generative AI. If you've been paying attention, you know that generative AI is changing everything. How we interact with machines, how content is created, and even how industries will operate.
So in other words, you think you still have a competitive advantage even as the market sort of shifts to inferencing?
We have a great position in inference because inference is just a really complicated problem. And the software stack is complicated. The type of models that people use is complicated. There's so many different types. It's just going to be a giant market opportunity for us. The vast majority of the world's inferencing today, as people are experiencing in their data centers and on the web, vast majority of the inferencing today is done on NVIDIA. And so I expect that to continue.
You said on the call a couple of times that you'll be supply constrained for both Hopper and then Blackwell chips well until next year because of the vast demand that's out there. What can you do about that? Are there any sort of levers you can pull to help increase supply?
Hopper demand grew throughout this quarter after we announced Blackwell. And so that kind of tells you how much demand there is out there. People want to deploy these data centers right now. They want to put our GPUs to work right now and start making money and start saving money. And so that demand is just so strong. It's really important to take a step back and realize that what we build is not a GPU chip. We call it Blackwell and we call it GPU, but we're really building AI factories. These AI factories have CPUs and GPUs and really complicated memory. The systems are really complicated. It's connected by NVLink. There's an NVLink switch. There's InfiniBand switches, InfiniBand NICs, and then now we have Ethernet switches and Ethernet NICs. And all of this connected together with this incredibly complicated spine called NVLink. And then the amount of software that it takes to build all this and run all this is incredible. And so these AI factories are essentially what we build. We build it as a holistic unit, as a holistic architecture and platform, but then we disaggregate it so that our partners could take it and put it into data centers of any kind. And every single cloud has slightly different architectures and different stacks, and our stacks and our architecture can now deeply integrate into theirs, but everybody's a little different. So we build it as an AI factory. We then disaggregate it so that everybody can have AI factories. This is just an incredible thing, and we do this at very high volume. It's just very, very hard to do. And so every component, every part of our data center is the most complex computer the world's ever made, and so it's sensible that almost everything is constrained.
Jensen, I want to ask about the cloud providers versus the other industries that you said are getting into the generative AI game or getting NVIDIA chips. You had mentioned that in comments in the actual release, and then we heard from CFO Colette Kress that 40%, mid 40% of data center revenue comes from those cloud providers.
As we transition from AI training to AI inferencing, we're seeing a major shift in the technology landscape. For those unfamiliar with the term, inferencing is where AI systems make predictions based on data, whether it's generating the next word in a sentence, the next pixel in an image, or even the next frame in a video. This is where things start to get incredibly complex. And yet, Jensen Huang's confidence in NVIDIA's position remains unshaken. For NVIDIA, inferencing used to be a secondary concern. Training AI models was the real challenge. But now, with the rise of generative AI, inferencing is front and center. It's no longer enough to just process data quickly. You need to understand it, adapt to it, and generate something new from it. And this is where NVIDIA shines. While other tech giants like Google and Amazon are working on their own inferencing chips, NVIDIA's versatile architecture allows it to maintain its lead. In fact, Huang is clear that NVIDIA's GPUs are already at the forefront of this space, running the vast majority of inferencing workloads across data centers and the web. The real significance here is that inferencing is now intertwined with generative AI, making it much more complicated than ever before.
Elon talking about the incredible infrastructure that he's building. And one of the things that's really revolutionary about the version 12 of Tesla's full self-driving is that it's an end-to-end generative model, and it learns from watching videos, surround video, and it learns about how to drive end-to-end and using generative AI. Predict the path and the how to steer how to understand and how to steer the car. And so the technology is really revolutionary, and the work that they're doing is incredible. So I gave you two examples. A startup company that we work with called Recursion has built up its supercomputer for generating molecules, understanding proteins and generating molecules for drug discovery. The list goes on. I mean, we can go on all afternoon, and just so many different areas of people who are now recognizing that we now have software and AI model that can understand and learn almost any language. The language of English, of course, but the language of images and video and chemicals and protein and even physics, and to be able to generate almost anything. And so it's basically like machine translation. And that capability is now being deployed at scale in so many different industries.
Jensen, just one more quick last question. I'm glad you talked about the auto business and what you're seeing there. You mentioned that automotive is now the largest enterprise vertical within data center. You talked about the Tesla business, but what is that all about? Is it self-driving among other automakers too? Are there other functions that automakers are using within data center? Help us understand that a little bit better.
Well, Tesla is far ahead in self-driving cars, but every single car someday will have to have autonomous capability. It's safer, it's more convenient, it's more fun to drive, and in order to do that, it is now very well known, very well understood, that learning from video directly is the most effective way to train these models. We used to train based on images that are labeled. We would say, this is a car, this is a car, this is a sign, this is a road, and we would label that manually. It's incredible. And now we just put video right into the car and let the car figure it out by itself. And this technology is very similar to the technology of large language models, but it requires just an enormous training facility. And the reason for that is because the data rate of video, the amount of data of video is so high. Well, the same approach that's used for learning physics, the physical world, from videos that is used for self-driving cars is essentially the same AI technology used for grounding large language models to understand the world of physics. So technologies that are like Sora, which is just incredible, and other technologies, VO from Google, incredible. The ability to generate video that makes sense, that are conditioned by human prompt, that needs to learn from video. And so the next generation of AIs need to be grounded in physical AI, needs to understand the physical world. And the best way to teach these AIs how the physical world behaves is through video, just watching tons and tons and tons of video. And so the combination of this multimodality training capability is going to really require a lot of computing demand in the years to come.
Jensen, as always, super cool stuff and great to be able to talk to you. Dan and I really appreciate it. Jensen Huang, everybody, founder and CEO of NVIDIA.
Great to see you guys. Thank you.
The competition is heating up, but NVIDIA isn't just sitting back. Huang highlights the company's ability to adapt, innovate, and create a flexible platform that can integrate into almost any data center architecture. The notion that NVIDIA is simply building GPUs is a gross oversimplification. They're creating AI factories, massive, intricate systems designed to run AI workloads at an unprecedented scale. And it's about how seamlessly these AI factories fit into existing infrastructures, providing solutions that work for both cloud providers and more specialized industries. Now, let's talk about the real game changer here, Tesla's self-driving technology. Huang doesn't just mention Tesla in passing. He emphasizes the revolutionary nature of their approach to autonomous driving. What makes Tesla stand out is how they're using generative AI to learn from real-world video. Tesla is using an end-to-end generative model that learns by watching video, predicting the next actions, and adapting to the physical world. The implications of this are massive, not just for Tesla, but for the entire automotive industry. In the coming years, we can expect self-driving technology to become the standard, not the exception. And NVIDIA's hardware is at the core of making this a reality. The beauty of this technology lies in its scalability. What Tesla is doing now could eventually be applied to any car manufacturer that wants to integrate AI into their vehicles. The future of driving is AI, and NVIDIA is making sure that it will be both safe and revolutionary. The future of AI is unfolding before our eyes, and NVIDIA is leading the way. The truth is, we're only scratching the surface of what AI can do, and the potential applications are limitless. From healthcare to entertainment, from automotive to finance, AI will touch every industry in profound ways. NVIDIA's continued innovation in AI hardware and software ensures that they will remain at the heart of this transformation.
Well, we're building AI infrastructure for the world. And it is very clear now that we're about $150 billion of AI infrastructure into a journey of trillions of dollars of infrastructure. And so we've got a lot of AI to build.
I was here last year, totally different feel, different vibe. Felt there was a limitation to it. What happened in 1 year?
Well, in 1 year, we made AI better. It's smarter now. It can reason. We made AI more useful. Just about every industry and every company. All these companies are all building AI into their systems and into their products. And we've got a lot more energy and a lot more land and just so much more desire.
I couldn't believe it when Jensen Huang said NVIDIA's building toward a $1 trillion AI roadmap. $1 trillion? That's unreal. But then you hear how fast it's moving. They've already hit $150 billion in AI infrastructure, and demand is going through the roof. In the past year, AI didn't just improve, it leveled up. It can reason, it's faster, and now it's built into everything from finance to entertainment to healthcare. Big names like Disney, GM, and BlackRock are teaming up with NVIDIA because they don't want to get left behind. Yeah, the chips are expensive, but Jensen explained why. They're insanely advanced. Most powerful chips on the planet. They save companies a ton of time and processing power, and they're helping businesses make real money from AI. McKinsey even said AI could add over $4 trillion a year to the global economy. That kind of impact puts NVIDIA right at the center of it. And the scale they're building for? It's wild. He said they can now connect millions of GPUs using silicon photonics. That's like building an entire digital brain. Even with talk of tariffs or global tension, Jensen didn't flinch. He's already making moves to bring manufacturing stateside with TSMC and Foxconn. You can tell, he's not guessing. He's already playing 5 steps ahead.
That all of that foundation knowledge is just foundation knowledge. What we really want the AI to do is to learn how to solve problems. Learn how to reason, apply rules, apply knowledge, break a problem down one by one, step by step, and solve problems. That's intelligence. But you can't teach an AI that skill of solving problems. You can't teach AI reasoning without first having a foundation knowledge of what are numbers, how do words work together, what's vocabulary, what's syntax, what's grammar, so that it could learn some basic knowledge. Once it has the basic knowledge like we have AI today, notice how quickly we're teaching them how to reason.
Right.
And so it's learning how to reason. It's learning how to solve problems. It's learning how to solve math problems, geometry problems, prove theorems, prove logic. It's starting to learn those things by itself, and so it's really fantastic.
Well, this next level, even now, when you look at a deeper search from GPT, when you look at Grok,
Yeah.
they have opinions.
Yeah.
They're thoughtful. They're not yes men anymore.
Well, they'll argue with you.
Right.
Yeah.
That's
Yeah,
happening now, though.
Yeah, it's fantastic. And
How
so
did that? Did you know it would be happening last year?
Well, I'm in the industry, so we see progress. And
You're in the kitchen.
I can tell you that AI is going to progress very quickly over the next several years, and the answers that it provides, it will be surely more accurate, surely much more contextually relevant, and it'll be able to answer and solve problems that are quite useful to us.
What can our nation and our government do to further what you're talking about?
Well, I think that our country should also invest in AI. We should, of course, be talk about the importance of the technology, apply regulation where it makes sense, but also invest in using AI across the country, in every.
Well, why don't we have a strategic AI reserve? We have one for something as meretricious as Bitcoin.
We should at least build the AI infrastructure so all of our scientists in the United States can use the AI infrastructure. And however it comes about, whether it's a strategic reserve, but the country needs to invest in an AI infrastructure.
Now, when we talk about this, we almost immediately talk about the Chinese and almost a Sputnik-like race in 1957. Are we being too small-minded, and we shouldn't be thinking about the amount of business you do with China? Maybe that things are much further along than that mentally? Are we constraining ourselves with these discussions about politics and tariffs? Are these too small?
I think it's safe to say that we can't hold any country back or anyone back in advancing and developing intelligence. And surely AI is just digital intelligence.
Okay.
And so I think everyone is going to develop it. If everyone's going to be developing it, let's make sure that they develop it on American technology, American architecture, and the American standards. And so that's what I would advocate. And then secondarily, I would say, let's make sure that we are creating the conditions and investing in a way that allows our country to be far, far, far ahead. And so everything that we can do to speed up our advancement, everything we could do to speed up education here, startups here, economic development here using artificial intelligence, we absolutely should.
No, but when there was this DeepSeek issue, your stock took a $600 billion hit. I tried to reach you. I was told it was quiet period, that we could have easily explained that this is actually good for NVIDIA.
Yeah.
Why not have said that during that period?
We were during a quiet period.
But you still came out 2 days before. It was 25 days, and then you did it in a video 2 days before.
Well, next time you should contact me directly, and I'll come out and explain it.
Well, because it's a good thing.
Yeah. R1 DeepSeek was a fantastic thing. And the reason for that is because R1 is the first open sourced reasoning model. What makes R1 incredible is that it reasons. That's why the answer is so good. And it breaks the problem down step by step. It asks itself while it's thinking. It comes up with several different options for the answer. It might actually verify that the answer is correct. It solves a quadratic equation, takes the number, plugs it back in, and makes sure that it actually solves the equation. And so it's a reasoning AI. This reasoning AI consumes 100 times more compute than a non-reasoning AI.
And that's you.
It was exactly the opposite. It was the exact opposite conclusion that everybody had. And it actually consumes 100 times more computing.
Well, it's kind of amazing because the people are threatened by quantum. Quantum may use 1,000 times more compute.
Well, we're going to have to go help all the quantum computer companies, and this is going to be the first conference at GTC where we have a quantum day. And so all of my friends in the quantum industry are going to come, and we're working together to create classical, quantum, hybrid computers, because a computer can't just be quantum, and we like quantum to be able to accelerate many algorithms. And so creating a classical quantum computer using this architecture we call CUDA-Q.
He's not talking about upgrades or small steps. He's talking about a future powered by machines that can actually think through problems. Not just predict text, not copy. Real problem solving. He described how AI is now learning the way humans do. Start with basics like math, vocabulary, logic. Then build up to reasoning. Models are already showing they can break things down step by step, check their work, and choose the best solution out of several. That's happening now. R1 is a perfect example. It's a reasoning AI model that uses 100 times more computing power than a standard model. Not less, more. That matters, because NVIDIA builds the hardware that handles this kind of scale. If future models need that kind of compute, there's nowhere else to go. He also talked about building infrastructure for the entire country, so researchers, startups, and students here in the US aren't left behind. He's pushing for national investment, not just regulation. He wants American talent working on American hardware. And when stock markets panicked recently, the data said the opposite of what people assumed. The new models increased demand for compute. That's exactly what NVIDIA builds.
When it comes to Tesla's impressive growth, it's not just about observing from the sidelines. For Tesla bulls and those with a keen eye for uncovering the next stock market gem, Seeking Alpha is your one-stop shop, offering the latest on Tesla, Tesla stock price targets, Tesla innovation, and everything Elon Musk. Clicking on the affiliate links in the description and making a purchase may earn our channel a commission.
The world needs robots. The technology of building general humanoid robots, which is going to be the most useful, of course, because we build the world around ourselves, that technology is incredibly hard to do. But for the very first time, with transformers and these large language models and the breakthroughs that we're seeing with foundation models, we finally have the technology necessary, we think, to be able to make a real contribution in this. When you take a step back and ask yourself, what would happen if we could scale intelligence, building robotics, the things that we're working on? The critical technologies necessary to build general humanoid robotics is just around the corner. And one of the critical pieces of technology is an AI model that understands the world. Just as we have an AI model that understands language now with ChatGPT and Llama and such, we need a world model, a language model of the world. The world needs robots. And one of the reasons for that is we just don't have enough workers. You know, there's a aging population and a changing in preference of the type of work that people want to do, and the birth rate is declining, and the world needs more workers. And so the timing is really relatively imperative that we have robotic systems. The technology of building general humanoid robots, which is going to be the most useful, of course, because we build the world around ourselves. That technology is incredibly hard to do. But for the very first time, with transformers and these large language models and the breakthroughs that we're seeing with foundation models, we finally have the technology necessary, we think, to be able to make a real contribution in this area. There are several things that we have to bring together. First, the robot has to understand us, and the breakthroughs in ChatGPT, for example, has really made that possible. But what's missing is that we now need a AI that understands the physical world. It has to understand the dynamics of the physical world, like gravity, inertia, friction, and it has to understand spatial relationships and geometric relationships. And well, the first part of training an AI is you have to give them foundation knowledge, okay, common sense knowledge. The second part is you have to fine-tune them in skills. You have to teach them things. And the way you teach a general robotics is kind of like the way you teach a person. You show it to them. And so you use human demonstration and you show them this is the way you pick up a glass. But every time the glass is a little bit different, its position a little different, the height's a little different, and the shape's a little different. And yet it's basically picking up a glass of water. And so using Isaac Groot, we could do a few human demonstrations, and then using AI, using Cosmos and Omniverse to generate a whole bunch of future versions of it. And so So then we generate a whole bunch of versions of different sizes and different locations and placements. And we give all of that training data, like imitation data, to the robot to learn from. And so now it learned a whole bunch of generalized versions of it.
Yes.
Yeah.
The way Jensen Huang explains it, you start to feel like we're standing right in the middle of a shift. Not in the future, but right now. He's talking about building AI infrastructure for the cloud, for enterprise, and for robotics. And you can hear in his voice that it's already moving faster than most people realize. He mentioned BlackRock, Disney, GM, Cisco, huge companies reaching out to say how critical this is. BlackRock's even planning a $40 to $50 billion data center. That's not a pilot program, that's full commitment. And it doesn't stop there. He's hosting a full quantum computing day at GTC. NVIDIA isn't sitting on the sidelines waiting for quantum to catch up. They're building hybrid systems right now, combining quantum and classical tech using something called Q2Q. That's already being adopted. It's wild to think that robots running on NVIDIA chips are going to be able to do things like decide how to make a bed or load a dishwasher. Not by following one hard-coded path, but by reasoning through each step. Should I stand this up or lay it flat? It has to make those decisions in real time. And he made it clear. That small chip inside the robot depends on a giant supercomputer behind it, training the model, feeding it intelligence. So every robot, every smart system we see in the world is backed by massive compute power running in the background. That's the part most people don't see. What's crazy is that just a year ago, everyone was still amazed by AI that could generate text and images. Now we're watching it reason, plan, solve problems, and make real-world decisions. And all of it is running on NVIDIA's tech.
But do you know who else shares in pro-Tesla optimism? That would be today's sponsor, Seeking Alpha. Seeking Alpha is the best pro-Tesla news source on the internet. Click the affiliate link in the description below to get the latest Tesla offering, price targets, innovation, and everything Elon Musk. Link in the description for a very special offer.
Well, the robotics industry has a hard time getting off the ground because it's hard to train a robot. And you have to create a whole bunch of experiences for the robot. And it's also hard, it's also dangerous to train a robot in the physical world. And so we created a virtual world where a robot could, a playground for a robot essentially. And so this Omniverse is a virtual playground. To the robot, it feels like the real thing because it obeys the laws of physics and things look real. And to the robot, it can't tell the difference. And so we train the robot in this virtual world called Omniverse, and we create a whole bunch of scenarios for the robot to learn from. Now, when the robot learns how to be in Omniverse and do a task in Omniverse, we take that robot brain and we put it into the real robot. And if the real gap is as small as possible,
XAI has now acquired X in an all-stock transaction, values XAI at $80 billion and X at $33 billion. In a post on X, Musk saying, quote, XAI and X's future are intertwined. Today, we officially take the step to combine the data, models, compute distribution, and talent. This combination will unlock immense potential. Joining us right now is Rich Greenfield. He's the co-founder and partner at Lightshed Partners. Good morning to you.
Hi.
What do you make of this? What do you think really led to it?
Well, I mean, part of me, Andrew, sort of believes that this was sort of always the plan, that this was sort of, everyone sort of wondered, like, why is Elon buying X? Like, why does he want to own Twitter? What is this really about? And I think as you look at sort of the AI arms race that is really unlike, if you look at the capital that's being spent and how intense the competition is between OpenAI and Google and Anthropic and X and Meta, this is an arms race of epic proportions. Here's Elon. He buys Twitter, has this incredible source with hundreds of millions of people creating exclusive data, information that flows through X every day. Sure, Threads exists and Blue Sky exists,
right,
but none of them have caught on.
Rich,
you're there,
I need
but
to
no
stop.
one's really using it.
I need to stop you just so we're on the same page and we're looking at the same set of facts. And I'm a big fan of a lot of the things that Elon has done. But let's just go backwards and go through the history of this, because you're making this out as if this was the original plan. And I just would recite to you what actually happened in reality. which was he wanted to buy X. At the time, said it was because it was a town square that he wanted to create a sort of a full town square where all sides could speak political sides. That was the original intent. And at the time also said that he thought it could become a financial services company. That's what he said publicly at that time. He then decided actually that he didn't even want Twitter at one point and actually went to court to try to avoid having to buy Twitter. So the idea that this was preordained from moment one is a little bit of a stretch, I think. Okay, then he gets it. The value drops precipitously, just what it was because of advertising and the like. And at the same time, he starts to build XAI and gives a percent of that business to the folks who owned X, in part, I think, not only because they were using the data, but as a make good for the fact that the value had dropped as much as it had. You can continue from there, but that's actually what happened.
I don't think you can dispute any of those facts. What I'm getting at, though, is a town square. Like, what was the ultimate purpose of building that town square? And we can debate whether it feels more biased one way or another. I'm sure everyone has their opinion of, like, what actually is happening on X. But
what do you mean? There's not a debate about it, Rich. Do you think there's a debate?
What I mean is there is still more dialogue that happens on X every day than what I see happening on Threads and on Blue Sky. Like
100%, but it's not. It hasn't turned out to be. Just look, and I say this just factually. It's not about having a political view. It hasn't turned out to be what I think the original intent was. You agree with that?
I would agree with that.
Okay, wow. Elon Musk just pulled off a massive move. XAI is now merging with X in a deal that's valued at $80 billion. That's not a typo. Billion with a B. And honestly, when I heard that, my jaw dropped a little. Now, some people are saying this was Elon's plan all along. But let's be real for a second. When he first bought Twitter, he said it was to make it a free speech platform like a town square. Then he said it could become a payments company. And then, remember this? He tried to back out completely. So no, it probably wasn't some master plan from day one. But here's what's wild. Whether it was planned or not, this move puts XAI in a crazy strong position. X has hundreds of millions of users posting real-time content every day. That's an ocean of fresh data, exactly what AI needs to get smarter. So yeah, OpenAI has competition. Big time. Elon's building this monster of a platform that combines users, data, AI talent, and distribution. And if he plays this right, XAI could be the one to beat.
When we started this conversation, it sort of went into this other place as if you were suggesting this was sort of the plan from moment one, and that he was the Messiah. And by the way, he may be the Messiah. I'm just saying it didn't happen that way.
I'm just saying we all were wondering, why did he want to buy it? Sure. Did he want to get out of it? And remember, we were on CNBC talking to you why he wasn't going to be able to abandon the deal, that there was no way out. But I don't think he actually wanted out as much as he wanted a much lower price. He realized he was massively overpaying, and that's Elon's mistake, and that's his problem. But the idea of having a global town square, having all of this information where, look, Andrew, I know
agree. I'm just saying Rich, all I'm suggesting is it was a pivot. I'm saying I don't believe, and I don't think you believe, maybe you do, that the original intent was an AI-focused intent, that he was going to hoover up all this data, that was the reason he was purchasing it. And I don't believe if you go back at all within the first 12 months of the purchase, before or after, that was part of any of the discussion.
We weren't even talking. I mean, OpenAI hadn't even broken onto the scene. We weren't talking about AI at that point.
That's my point.
However, what is inside Elon's brain and what was really going on is something that we're never going to really know. What we do know, Andrew, is that going back to that original why Twitter, why X, was because it had incredibly unique information that couldn't be found anywhere else on real-time conversation all around the world, and had failed to live up to its potential under prior management. That's the facts. And so whether he paid the right price or not, whether he realized he was going to shift this into AI or into some other thing, the idea was he had an incredible amount of content and real-time information that 100%. Couldn't be found anywhere else.
We're
and I believe,
100% aligned
what's
in that
happening.
regard.
And what I believe is happening
Rich, it
is
took
he is
10
worried.
times as many employees to make sure you did nothing on the laptop or the Wuhan lab origin. So, get rid of 90% of the employees and actually start putting every side of an issue on Twitter. So I would say Messiah, yes, whether he lost or not. But what did you say?
What I'm getting at, Andrew, and what I think is really
I say he might be the Messiah. I'm not saying he's
Okay.
not. I'm just saying that in the context of how this whole transaction came about and what the original origin story really is relative to the way Rich portrayed it from the beginning, I think is a little bit different. Having said that, I think he made the pivot, and he's obviously been very successful making that pivot.
I'm not saying it was a Trojan horse to AI when he announced the original transaction.
Right. And that was the point I was trying to make.
It was a Trojan horse for something. It wasn't about buying an ad-supported Twitter. That was certainly not the goal. I don't even think he really likes advertising all that much. But the reality is there was a plan to use this data for something bigger. And I think what's really interesting about this transaction of going from 10% ownership to it being completely owned by XAI is now there's no debate, no fiduciary responsibility to sell this data to anybody else. This now can be proprietary to XAI.
So here's the reality. Elon didn't buy Twitter with some grand AI master plan in place. Back then, it was all about free speech and creating a town square. AI wasn't even the main conversation yet. And let's not forget, he tried to walk away from the deal when it got too expensive. But what did draw him in was the data. Twitter, now X, has something incredibly valuable: real-time conversations from all over the world. That stream of information is exactly what advanced AI systems need to learn and improve. Now that XAI fully owns that pipeline, there's no middleman, no board, no shareholders, just Elon and his vision. Whether or not it started as an AI play, it is one now. And with this merger, XAI just gained the kind of data edge that companies like OpenAI and Google can't replicate.
If you're following Elon's moves and how government policies impact markets, you need Seeking Alpha. It's my go-to for expert stock analysis to help you stay ahead. Check the link in the description for a special offer. Our channel may earn a commission.
OpenAI eclipsing XAI in the fundraising race in artificial intelligence, raising $6.6 billion, surpassing the $6 billion that was just raised by Elon Musk's XAI back in May. Joining us right now to discuss what is turning out to be quite the AI tech race and so much more is Walter Isaacson. He is the author of Elon Musk. He's also a Perella Weinberg advisor, partner, a Tulane professor, and importantly, a CNBC contributor. It's nice to see you.
And friend of Andrew. Yeah.
And I'm very happy to say.
And Becky.
Friend of Squawks.
Friend of Bill.
Walter, what do you make of this race, where you see OpenAI, which seems to be clearly, I think, in the lead relative to everybody else, but you may think that everybody's very, very close to each other, and then XAI, which, by the way, at least by my eyes, has actually caught up or gotten very close very, very quickly.
Yes, XAI has caught up very much, and I saw Musk and Sam Altman together about a week ago. And there's, of course, a large bit of tension that goes back 4 or 5 years when they both started OpenAI, and now Sam is taking OpenAI and making it no longer open and no longer not for profit. And also telling people, if you invest in us, we don't want you to invest in others. What will be interesting is the script getting flipped a bit next week, October 10th, when Elon introduces robotaxi and things that operate in the real world. When Musk bought Twitter, he got this huge data feed of a billion tweets a day. When he has Tesla, he has 1 billion frames from cars every day. That's the data. The big thing you need is the data set to train on, and the big next leap is real-world AI, cars that drive themselves, robots that walk.
Well, one of the questions becomes how XAI is going to be integrated or not into the development efforts of these other products.
And let me tell you one thing about
Tesla,
Elon Musk is that he tries to integrate everything. He's not going to set up walls and silos, even though some, Tesla's publicly traded, XAI.
Well, that's what I was going to ask. So there's going to be an investor class that's in XAI, as we know. There's an investor class that's in Tesla. There's another investor class that's in SpaceX.
Look, when he took over Twitter, he brought engineers from Tesla and other companies to help build the AI there. He blurs those lines. Plus, he even has Neuralink, the company that's implanting chips in the brain. So if you're wondering, is he going to bring all these things together? My answer is yes.
I ask you a question about just the ability for him to advance as quickly as he has. I mean, literally, there was no true AI effort in terms of inside XAI that didn't exist a year ago.
I remember he called me to, Austin, Texas, and sitting in the back of, by a swimming pool in a house somebody had rented. He's telling me, I'm going to start from scratch an AI company because I don't trust Sam Altman.
So how much, though, is this a business that is just a function of processing power? If you have enough money to buy enough chips and you can get NVIDIA to give them to you or to sell them to you, that you can be not just a player in this game, but be one of the top tier players. How much is it that versus the alchemy, the sort of software talent, the engineering talent to be able to write algorithms? And how is it possible that in a year or less, this group has managed to do it while Google, which was clearly at the, they were the vanguard of all this at the beginning. And I actually think inside Google, they have all of the same type of talents, but I don't know if they have struggled to productize it or what's happened here. But it looks very different.
Yeah, and Google, you have Google DeepMind. They do Gemini, and it's Demis Hassabis, who is, in my opinion, the greatest mind at the moment looking at AI. But you're right. At the moment, Gemini is not racing ahead of Anthropic or XAI or OpenAI. I think that part of it is Musk was very smart and good at getting NVIDIA chips, getting CPUs. That's one of the gating factors. He's creating his own chip, which is taking a longer time, a Dojo chip, which is going to do visual data. So and once again, you saw that blurring of the lines. He was getting some of the NVIDIA chips for, I think, Tesla, and then he was moving it to XAI.
But his plan is not to be open either, by the way.
No.
Right. So this whole idea of, he can be frustrated or upset that he thinks that OpenAI is not open, but he's building his own closed system too.
Of total consistency.
Is it about who controls it? And do you have more faith in Elon Musk controlling it than Sam Altman?
I mean, from a very elevated perspective, having watched Musk very up close for a couple of years, I'm going to say something that you might think is naive, but I really believe it, which is he has certain missions he's had his whole life. He read Isaac Asimov. He read the Robot series. He thought the robots might turn on us. I have to come in and save us from hostile AI. I have to make us multiplanetary.
Do you think he will? I believe you 100% on his idea of a mission. I think that's who he is.
I always think after, at the very beginning, I think, man, this is definitely starting an AI company, buying Twitter.
No, I just mean, do you believe him? Do you think AI is safer in his hands than in Sam Altman's hands?
I don't. No, I don't know. I wouldn't make that judgment. I'm sorry not to give you a snap answer here, but that's
It's a complex question.
Here's the real question of what he believes versus others. Is that the more AIs you have, does that make it safer? If there's 12 companies, 20 companies competing AIs, does that make it safer? Or is it better to be concentrated in the hands of a few, like Google,
he's like Lena Khan.
OpenAI? And Musk believes the more is the merrier because they'll check each other.
How many ultimately
that's a very good point. That's a very important point.
That was an early thing.
How many do you think there ultimately will be? Because there's some arguments you made there's going to be a lot of smaller language models, but these sort of what they call frontier models, these sort of large language models that cost a fortune to run. At some point, don't you think that they will either get merged or people will say, look, we'll take all that processing power and put it towards this or what? So are we going to be down to 2 or 3 in the end, or do you think this is a 5 or 6 or 7 player race?
I think it's 3 or 4, and I think you're right. There's certain natural factors that mean you need enormous amounts of electricity. Microsoft trying to open 3 Mile Island nuclear plant again. You need enormous amounts of CPUs, things like that.
Now, keep in mind, this conversation happened 6 months ago. And even back then, XAI was moving at lightning speed. Elon went from casually mentioning he didn't trust Sam Altman to building a full-blown AI company that's now neck and neck with OpenAI. That's wild. At the time, OpenAI had raised over $6 billion, way ahead in funding. But XAI was already catching up by using everything Elon had: Twitter's real-time data, Tesla's massive video datasets, and even pulling talent across all his companies. No walls, no silos, just total integration. And the big focus? Real-world AI. Not just chatbots, cars that drive, robots that move, systems that interact with the physical world. That's where Elon is headed. Now, fast forward to today, and we're seeing the gap closing even more. Elon's betting big that combining compute, data, and hardware in one tight loop is the future. He's not just building a chatbot, he's building an entire AI infrastructure. So yeah, 6 months ago, it looked like XAI was late to the party. But now, it's not only caught up, it might actually be the one to watch.
How big a threat does DeepSeek pose to America's tech industry? I mean, it has almost all the features and functions of the programs that we're seeing like OpenAI, but a fraction of the cost. And what is the emergence of DeepSeek, which has even won praise from the U.S. tech industry? What does it say about America's AI tech? Has it been overspending and under-delivering?
It looks like a massive threat. Here is a cost advantage that we haven't seen. It's something we call exponential efficiency. And at 6 million versus hundreds of billions of dollars, it looks like they found a crack into this. But the short answer is it's not that easy to do. And what you're going to see is it doesn't necessarily solve all your problems, but we now know that there's a way to deliver AI at a fraction of the cost and the ability to do that with open source models. And that's what we're all hoping for in the AI world, because unlike the internet, right now AI is closed, it's centralized, it's expensive, and there are few players. And if we were trying to get an internet level explosion, you need decentralized, open, you need cheaper and a lot more players to be able to be in this model. And so what they've shown is that this is possible. But the challenge is AI isn't that easy. And so, yes, you might be able to solve that model in this manner, but it's going to take a while to get the refinements as well. So there's a lot more to do to get to AGI. But this is a very interesting thing in terms of rattling markets by saying, is the US spending too much? Are we spending too much on data? Can we do this with less energy? And that's the right question to ask, because we want to see technology costs come down over time.
In the fast-evolving world of artificial intelligence, the race for supremacy isn't just about who builds the smartest model. It's about who can build it faster, cheaper, and make it truly useful. Recently, a Chinese AI leader, Kai-Fu Lee, dropped a reality check that has sent shockwaves through the tech world, especially for Sam Altman and OpenAI. Kai-Fu Lee is pointing to a strategic leap that challenges everything we thought we knew about how AI companies compete. At the center of this is DeepSeek, an open-source AI model that, according to Lee, is running at a fraction of OpenAI's enormous operating costs and still delivering impressive results. Imagine running a top-tier AI system at just 2% of the cost of your biggest competitor. That's a potential game-changer, but it's not just the cost savings that matter. DeepSeek's strength lies in its adaptability, how it can be molded to work seamlessly with real-world business systems like finance, insurance, and customer service. Kai-Fu Lee's company, 01.ai, is building the missing pieces, the middleware and interfaces, that turn DeepSeek from an impressive AI kernel into a practical tool that companies can actually use every day. This is where the real challenge to OpenAI emerges. For all its breakthroughs, OpenAI's model remains costly and resource-intensive. The question Lee raises is clear. Can OpenAI maintain this expensive pace when a competitor offers a similar quality model for free, with the backing and funding to sustain it long-term? This is grounded in the economics and realities of AI development today. The founder behind DeepSeek has the financial stamina to keep this open-source model alive and evolving. Meanwhile, OpenAI is burning billions annually. This financial pressure adds a new layer of complexity to the AI race, beyond the technical prowess of the models themselves. Moreover, the Chinese AI landscape is poised to support just a handful of major players, with DeepSeek currently leading, alongside giants like Alibaba and ByteDance. That means market momentum is crucial, and 01.ai is betting big on DeepSeek's future. The analogy Kai-Fu Lee draws between AI foundational models and operating system kernels is telling. Just as the Windows kernel alone is useless without the software ecosystem that runs on top, the value in AI now lies in those practical layers, the applications, the user interfaces, and integrations that turn raw AI power into real business advantage. Investors see this shift clearly. The days of pouring massive funds into new pioneer models are waning. Instead, capital flows toward AI infrastructure and applications that deliver tangible solutions. One might wonder if US tech sanctions and limited access to advanced chips could slow China's AI advance. But Li argues the opposite happened. Facing those restrictions forced Chinese developers to innovate smarter and more efficiently, cutting computing costs dramatically and reinforcing their competitive edge. The pace of AI development is blistering, with frequent releases from leading companies. China's strategy of combining open-source models, smart infrastructure, and strong local government support is propelling its AI industry forward at breakneck speed. So, where does that leave OpenAI and Sam Altman? Facing a bold and cost-effective challenger that's not only competing on technology, but rewriting the rules of AI economics and deployment. It's no surprise that this challenge could keep Sam Altman awake at night. This is a glimpse into the future of AI innovation and global competition. Stay tuned as we unpack the full story behind this bold move from China's AI frontier. You don't want to miss what's coming next.
If you think about OpenAI's cost of $7 billion of operating costs in 2024, DeepSeek probably operated with 2% the operating expense. So with that kind of formidable competitor, I think Sam Altman is probably not sleeping well.
Kai-Fu Lee, one of China's top AI leaders, just explained why China's approach to AI could shake up the entire industry. And he did it in a way that left Sam Altman with a lot to think about. In this video, we break down what he said and why it matters.
I mean, it's perfect timing because you've just launched an enterprise large language model that's also going to be deploying DeepSeek more broadly. But talk us through exactly what it entails.
Yeah, well, I think China had its ChatGPT moment when DeepSeek came out. We can call it DeepSeek moment. Everyone's aware of it over the Chinese holidays. Everyone's talking about it, and the CEOs came back to work saying, "Put DeepSeek to work at my company." And what they found out was DeepSeek is a fantastic model, amazing AI, but it doesn't have the middleware and the user interface that it takes to connect to corporate databases, to build applications, to make it useful for HR, finance, and customer service. So what 01.ai did was we saw DeepSeek has been making great momentum, and we decided to really bet on DeepSeek and build that missing middleware and UI so that DeepSeek can be made useful in corporations. That's the product we announced this Monday, and we're getting fantastic reception in China and also in Hong Kong.
Tell us more about that launch.
Yeah, so we launched on Monday, and what we talked about was many of you have DeepSeek now. You love to use it. In fact, one CEO friend of mine asked his employees, "What do you use it for?" And good question. And the answer was fortune telling. By the way, that's a great thing to try for you, but it's not very deep into the industry, the company. You know, every company has ERP and the CRM databases. They have employee records. They have their internal information, and they want the model to be more a generalist. They want it to be knowledgeable. Bloomberg would want a finance knowledgeable model, right? Ping An would want an insurance knowledgeable model. So our job is to really build that layer for that purpose. It's sort of like if I gave you a Windows kernel that is the core operating system, you wouldn't know what to do with it. You need all the Windows layer, the application interfaces, so that the Windows kernel can be useful, and we like to think that 01.ai is providing that layer for DeepSeek, which is the underlying model and technology.
And using DeepSeek as the underlying model, I mean, obviously you could have chosen other models instead, including from the US. What does that tell you about where the competition or I guess the race for supremacy stands between China and the United States right now?
Well, clearly, in both U.S. and China, the pre-training of a giant model has consolidated and is consolidating, and it's become clear that open source will be the winner. There's still many that will not concede. Right, OpenAI, Anthropic, who build their businesses believing they can build a better closed model than everyone else. I think they got shocked when they saw a model as good. they would argue nearly as good, but either way, they're getting it for much, much lower cost. If you think about OpenAI's cost of $7 billion of operating costs in 2024, DeepSeek probably operated with 2% the operating expense. So the issue really isn't whose model is 1% better. I think they're all very good. But the issue is OpenAI's model even sustainable, right? I mean, you're spending $7 billion a year, making a massive loss, and here you have a competitor coming in with an open source model that's for free. And that company also is infinitely lasting because this founder has enough money to fund it at the current level and has reduced the cost of computing by a factor of 5 to 10. So with that kind of formidable competitor, I think Sam Altman is probably not sleeping well.
Kai-Fu Lee just laid out a pretty serious challenge to Sam Altman and OpenAI, and it's one that might keep Sam up at night. He explained that in China, DeepSeek, an open-source AI model, suddenly took off. Everyone was using it, but businesses quickly realized it didn't have the tools to connect with their actual systems, like databases or CRMs. So Kai-Fu Lee's company, 01.ai, stepped in to build those missing parts, the middleware and user interfaces. So DeepSeek could actually be useful in industries like finance, insurance, and customer service. And here's where things get intense. Kai-Fu points out that while OpenAI is spending billions to build and run their models, reportedly $7 billion this year, DeepSeek is running at just 2% of that cost. That's a huge difference. On top of that, it's open source and backed by a founder with the money and efficiency to keep it going long term. He's not saying one model is a little better than the other. He's saying, can OpenAI even keep this up when a serious competitor is giving people similar quality for free?
Yeah, well, you do think, I mean, obviously, that DeepSeek would have really challenged some of the monetization strategies around AI. But at the same time, given that AI is so commoditized now, and in China as well, that open source approach, how many AI models do you think that the Chinese market can actually sustain?
Well, I think probably, I'm guessing 3, DeepSeek, Alibaba, and ByteDance. And they'll evolve over time. Right?
Okay, there's a few names missing on that list.
Yeah, well, there will be many other who aspire to build one, right? And we'll see if there's a 4th player. But even within these 3, I think DeepSeek currently has the momentum, and that's why we're embracing that. But I also want to point out that I wouldn't say AI is commoditized. I would say the underlying pioneer model, foundation model, that is trained with a huge amount of money is commoditized. It costs a lot and it's hard to really compete with open source. But AI is not commoditized, right? It's like, Windows kernel, Linux kernel, that's kind of commoditized. But Windows is not commoditized. Microsoft makes a ton of money. And what 01.ai wants to do is build Windows and use DeepSeek as our Windows kernel.
And is that where you think the value added comes now? In other words, for VCs thinking about where the value added is in this industry, it's no longer, for example, AI, for example, still presents that value. And I want to understand, for example, the economics and why you think, say, there's only room for 3 as well.
Well, there may be room for 4, but in most markets, you end up with room only for 2. Right? The winner who makes a ton of money, the runner-up who breaks even, and everyone else who dies. And this one is exacerbated because it's hard to monetize the underlying pioneer model. But once you are the winner, there are many ways to monetize it. Right. So that's the trick. For the VCs in both US and China are moving away from wanting to fund more pioneer models. They're happy to fund AI infrastructure, AI applications, consumer apps, because every app will be remade, right? And also enterprise apps that can provide real value add to enterprises. So AI funding is going gangbusters. It's just that nobody wants to fund pioneer models.
Does China's innovation, though, come up against the headwind this year of greater restrictions on China's access to advanced semiconductor technology? Is that going to end up presenting a problem?
So we can look at historically, right? China is able to catch up and build great engineering products while US is better at making breakthroughs. That was what I argued in AI Superpowers, and that continued to be the case. The GPU sanctions came 2 years ago. And today, we actually see DeepSeek not only resilient, competitive, but also basically made true the statement that necessity is the mother of innovation. That because they had so few GPUs, they had to make it 10 times more effective. So I think I would argue that the sanctions so far hasn't worked. It's hard to project the future, but I would say that DeepSeek actually benefited from having less resources and able to make training and inference at 5 to 10 times lower the expense incurred by OpenAI and others.
Kai-Fu Lee explained why DeepSeek is gaining real ground in China. He believes the market can likely support 3 main AI models: DeepSeek, Alibaba, and ByteDance. Right now, DeepSeek has the lead, which is why his team at 01.ai is building on top of it. He compared the current stage of AI to early operating systems. The core models might be widely available, but the real value comes from what gets built around them: the user interfaces, the tools, the connections to company systems. That's where companies can create something people actually use. Venture capital is following that shift. Investors are moving away from funding massive foundation models. Instead, they're putting money into infrastructure, apps, and AI tools that solve specific problems for businesses. As for hardware limits from US sanctions, Kai-Fu said the results speak for themselves. DeepSeek became more efficient, cutting training and computing costs by 5 to 10 times.
You know, I remember, so DeepSeek was, what date is it? March 20, so let's call it 2 months ago. I remember we had the chat on the show, I think it was back in October, where you guys actually launched something similar months before DeepSeek. And so you guys came out, DeepSeek came out, and then since DeepSeek came out that moment, just the cadence and the frequency of all these ones coming out with their own iterations of it. I guess my question is, what do you make of the frequency? What is behind, you think, the frequency of these releases? And is DeepSeek the symptom or is it the cause of what's going on? In other words, what can we expect from the industry this year?
I think it's still ultra competitive. The fact that I think China will have 3 winners, US might have 4 winners at the end, doesn't mean dozens of others will not want to compete. So I do expect frequent releases to continue especially from the fast-moving companies. And I think the fastest moving companies probably are xAI's Grok and DeepSeek. I'd say these are the fastest. And then I think OpenAI, Alibaba, Google, and Anthropic are, of course, all making respectable moves. I listed ByteDance because they're not on the list by people, but we know how much they're spending. And I think one way you can justify spending a ton of money on pioneer models is because you have so many customers that when amortized over many, many customers, you can make the business case. And ByteDance has more customers and more ways to monetize than anybody, so I would make that speculation.
Yeah, I think Baidu is one of the names that sort of stands out to me, not on that list, and maybe you can share some reaction on that, but also government support from Beijing. Exactly how do you see that also shaping up over the coming year?
Well, we all respect and thank Baidu for really starting the transformer revolution in China. They tried to hire Jeff Hinton and ended up hiring Andrew Ng. And I think that shows that Robin has that kind of vision. The execution is currently lagging, and we'll see what happens. And your other question was?
Government support.
Government support, right. So the Chinese government's new big direction is called New Quality Productivity. What that means is using high tech to create productivity, efficiency, and really turn all the traditional industries into more profitable, more competitive by the use of high tech, and AI is at the very core of that.
Actually, sorry, a final question for you. Because you mentioned the word consumption in AI was actually mentioned in Premier Li Chang's work report from the NPC, and to the point that Mel was making on, government support, it was rare that we saw just, the CEOs of China's big tech companies in the same room as the president, for example, weeks before that. And I'm wondering tangibly, what measures do you think we could see from the government to be able to back up, really, what really seemed as very, very good optics?
Yeah, I think right now the local governments probably are the most active in trying to see, I'm City X, I'm the party secretary, mayor of City X, and this city is very strong in the following industries. How would I apply AI to create this new quality productivity in these industries? That will end up helping the growth, the GDP of the city. And I think, having a single direction from the top, new quality productivity is very, very effective and invigorating to the cities. And we're seeing a lot of interest for our company and our peer companies to work more closely with these local cities.
Kai-Fu Lee ended by pointing out how fast the AI race is moving, especially in China. He said companies like DeepSeek, SAIC, and Gronk are releasing new models at a rapid pace. In his view, China will probably have 3 leading AI players, while the US may end up with 4. But that doesn't stop dozens of others from trying to compete. He also brought up ByteDance, not often mentioned in AI conversations, but they're spending heavily and have a huge user base. That scale gives them more ways to recover costs and turn AI into a real business, which makes them a serious contender. When asked about government support, Kai-Fu explained that China's new strategy, called New Quality Productivity, is all about using high-tech tools like AI to boost traditional industries. Local governments are already jumping in, asking how AI can improve their region's economy. His company is now working with several cities to help turn that vision into results. So while the global AI race continues, China's approach is picking up speed. And it's not just about building models. It's about turning them into tools that drive real economic change. The global AI race is moving faster than ever, and Kai-Fu Lee made it clear China isn't falling behind. With open source models, smart infrastructure, and strong local support, they're building real momentum.
We have an AI and robotics fund, and we hold probably most of them because they are going to benefit from the declining cost in AI. And even Meta, who was really the open source leader, DeepSeek is open source.
Kathy Wood just dropped a major insight, and honestly, it's hard not to get excited. She says the cost of innovation is collapsing, and she's not exaggerating. According to data from ARK, the cost to train AI models has been falling about 75% per year, and inference, the part where AI is actually used, is getting cheaper by up to 90%. That's a game changer. And here's where it gets interesting. She's saying this shifts the power away from just the chip makers like NVIDIA, which dominates training, and toward companies that actually apply AI in the real world. That includes Palantir, one of ARK's top holdings. With AI becoming more affordable, tools like Palantir's platforms are suddenly way more scalable. What really caught my attention? Her point about healthcare and autonomous mobility. She's saying AI combined with things like gene sequencing and CRISPR could help cure diseases. That's not hype. Companies like Illumina and CRISPR Therapeutics are already showing promising data in this space. And when she mentions DeepSeek, that's serious. China's AI models are catching up fast, but she sees that as a good thing. More competition, lower costs, and more breakthroughs. Honestly, if she's right, we're looking at a wave of innovation that everyone can benefit from.
I want to try and understand something you mentioned very briefly, which is the strategic importance of not just the equity stake, but the partnership on technology, and not just for NVIDIA, but for America. Why are you moving into this domain?
We announced a brand new platform for a new market we've never been in. And so that's number one. If we take advantage of this transition from general purpose computing to accelerated computing, from old types of software to AI, we can take advantage of this transition of AI and 6G for America to win back telecommunications.
For decades, the world's communication networks were built by giants, names like AT&T, Ericsson, and Nokia. But somewhere along the way, America lost its edge. The backbone of global telecommunications drifted toward foreign suppliers, and innovation slowed to a crawl. Until now. Because Jensen Huang just announced something that could completely flip the balance of power, not just in tech, but in geopolitics. NVIDIA is teaming up with Nokia to rebuild the world's telecom infrastructure using AI, accelerated computing, and 6G technology. And this move could change everything. At NVIDIA's GTC event, Jensen Huang revealed a partnership that no one saw coming. A collaboration that fuses NVIDIA's AI supercomputing with Nokia's global telecommunications reach. He said, "For the first time, America can build telecommunications networks on American technology." That statement hit hard, because what Huang is describing isn't just another upgrade in wireless speed. It's a return to technological sovereignty. For decades, America's communications hardware has been powered by non-US companies. Now, for the first time in years, an American-led alliance could bring that dominance home. Here's the vision. Combine NVIDIA's accelerated computing with Nokia's air-scale base stations, which power millions of cell towers around the world. That means NVIDIA's AI systems will be embedded directly inside global telecom networks. If that sounds small, think again. It's like installing a supercomputer in every cell tower on Earth, capable of processing real-time AI tasks at the speed of light. This changes the game completely. I won't just run in data centers anymore, it will run inside the network itself.
And it's been a long time since the American telecommunication network has been built on American technology.
Fairly profound happened this year, actually. You look, in the beginning of the year, everybody has some attitude about AI. That attitude is generally, this is going to be big.
National security, I believe.
For national security reasons, for economic reasons, our industry should be built on American technology, and for the very first time, we can do that. We have a brand new product line.
It's going to be the future, and somehow, a few months ago, it kicked into turbocharge. And the reason for that is several things. The first,
that takes advantage of computing, accelerated computing, and AI, and we have a great partner to help us do it with, Nokia.
Is that we, in the last couple of years, have figured out how to make AI much, much smarter. Rather than just pre-training.
The market reaction kind of speaks for itself. There was a time when Nokia was already looking to America. You've been in the role since April.
Pre-training basically says, let's take all of the information that humans have ever created, let's give it to the AI to learn from.
But may I start by asking you what role the administration played in bringing you both together if this is indeed a strategic priority?
It's essentially memorization and generalization. It's not unlike going to school back when we were kids.
I don't think there was anything specific that the administration did, other than they've created the environment to support innovation. I mean, Jensen's talked about manufacturing.
The first stage of learning. Pre-training was never meant, just as preschool was never meant to be the end of education.
Innovation and technology leadership. And if you think about where this world is going and all those incredible devices that are going to be built on NVIDIA platforms.
Pre-training, preschool, was simply teaching you the basic skills of intelligence so that you can understand how to learn everything else.
Robotics, autonomous vehicles, augmented reality, virtual reality. We need a different kind of network in the future, and that's what we realized.
Without vocabulary, without understanding of language and how to communicate, how to think, it's impossible to learn everything else.
And that's why we wanted to forge this partnership, so that we're building a network leveraging AI for AI services.
The next is post-training. Post-training, after pre-training, is teaching you skills. Skills to solve problems, break down problems.
And that's really the big change here.
And the technology is flowing both ways. I mean, what is it that you will be able to do with Nokia, Jensen, that you weren't able to do on your own?
Reason about it, how to solve math problems, how to code, how to think about these problems step by step.
Nokia's CEO described it simply. We're building a network that leverages AI for air services. In plain terms, that means AI will optimize everything, from how your phone connects to a tower, to how autonomous vehicles communicate on the road, to how robots in factories synchronize with precision. This is AI-driven 6G, and it's the infrastructure of the next industrial revolution. For NVIDIA, this is strategic brilliance. They're no longer just the chip supplier for AI labs. They're embedding their hardware into the nervous system of the world's communication grid. But there's a deeper layer to this move. Huang said this partnership could allow America to win back telecommunications again. That's not just business talk, that's national security. Because for years, companies like Huawei dominated the global 5G rollout, giving China control over much of the network backbone. This NVIDIA-Nokia alliance represents the counter-strike. It's an effort to make sure the next era of wireless, 6G and beyond, is built on Western technology, protected from foreign surveillance and influence. The partnership isn't just symbolic. NVIDIA isn't just collaborating. It's investing directly in Nokia, taking nearly a 3% equity stake in the company. Jensen called it an investment in the future we're building together. That's a bold move. Not just a handshake, but a declaration that NVIDIA wants skin in the game. It signals confidence that Nokia's AI transformation is about to pay off big. And the market agrees. Since the announcement, Nokia's stock has jumped, signaling that investors see this as a long-term realignment of the telecom landscape. Here's what makes this partnership different from the old model of telecom innovation.
Well, first of all, Nokia is in all of the world's base stations. And this AirScale platform of Nokia is in millions of base stations around the world.
Use first principle reasoning. And then after that is where computation really kicks in.
If our computers are not inside that base station, it doesn't help. It's no different than NVIDIA's computing platform's not inside a car, it doesn't help. The first thing is we need a partner to get us into the world's space stations. We also, remember, we're bringing AI to radio network.
But ever since, I've learned more, thought about more, and the reason for that is because we're constantly grounding ourselves in new knowledge.
AI to RAM, so that we can make wireless tech communications a lot more efficient. Second, we're bringing AI for the radio. On top of these radio networks and these telecommunication network, we're going to be able to provide AI services.
We're constantly doing research, and we're constantly thinking. Thinking is really what intelligence is all about.
Which is going to be able to make it easier for us to do robotics and autonomous vehicles and industrial automation and reach all of the different places around the world. That's kind of hard to do with Wi-Fi.
Now we have three fundamental technology skills. We have these three technology, pre-training, which still requires enormous amount of computation.
Cellular reads everything. And so we now have this fabric that we can deploy AI computing services on top of it. It's going to be completely revolutionary.
We now have post-training, which uses even more computation, and now thinking puts incredible amounts of computation load.
In your world and in your market, Huawei is an influential player, not just in Europe, I think also about the Middle East and Africa. How important is the relationship with NVIDIA to be able to counter, what Huawei does in those markets?
Look, I think for us, one of the principles I've had with my team since coming in has been do what we can do that no one else can do, and that is AirScale.
On the infrastructure, because it's thinking on our behalf for every single human. The amount of computation necessary for AI to think, inference, is really quite extraordinary.
What we do with AnyRAN software, the software that runs on it, that we're going to be putting on the NVIDIA ARC platform, that do what we can do well and partner with the best everywhere else.
Now, I used to hear people say that inference is easy. NVIDIA should do training. NVIDIA's going to do, they're really good at this, so they're going to do training. That inference was easy.
And this is a clear opportunity to partner with the best. And by the way, that's where America and the Western world succeeds.
How could thinking be easy? Regurgitating memorized content is easy. Regurgitating the multiplication table is easy.
Because we don't necessarily have one company doing everything like Huawei. We succeed because we partner aggressively.
Traditionally, upgrades, like 4G to 5G, required massive physical overhauls, new towers, new hardware, new chips. But NVIDIA's platform changes the entire equation. Instead of ripping out equipment, updates will happen through software. NVIDIA's Q2AI stack allows new capabilities to be deployed like an app update, instantly. That means if standards evolve, if protocols shift, or if entirely new AI systems emerge, networks can adapt overnight. The slow, expensive, decades-long upgrade cycles of telecom are gone. We're moving towards software-defined infrastructure, intelligent, flexible, and constantly evolving. This is exactly why Nokia's leadership called it a partnership with the best. They know their strength lies in global reach. Millions of base stations across 100+ countries, but they also know the future belongs to those who master AI. By embedding NVIDIA's accelerated computing directly into their AirScale systems, they're transforming those towers into AI-ready infrastructure. Together, they can deliver AI-powered services directly through the network, from edge robotics to connected cars to industrial automation. In Jensen's words, we're bringing AI to radio networks. That means the very airwaves that carry your data could soon carry AI processing power. It's also a signal to the rest of the world. For Europe, it's a lifeline. For the United States, it's a reclamation of leadership. And for companies like Huawei, it's a warning shot. Because Nokia and NVIDIA aren't just matching China's scale. They're creating something smarter, faster, and harder to replicate. By leveraging NVIDIA's accelerated computing and Nokia's software-driven 6G framework, they're setting the standard for global communication in the AI era.
If you watch GTC today, it was hard to not find it obvious that you're partnering with everybody. But that's the advantage, is this partnership.
Thinking is hard, which is the reason why these three new scaling laws, which is all of it in full steam.
We let NVIDIA do what they do best, and ultimately our customers win, and ultimately for America, I think America will win because there'll be more innovation faster.
Telecommunications better than Nokia. They've been at it for a long time. They're all over the world. And between our two partnerships, we now have wireless telecommunications, AI, and we have accelerated computing, all in this partnership. And so all of that capability is going to be brought to bear for the next generation of 6G. I think that's the capabilities we bring together in this partnership is quite unique and formidable.
Has put so much pressure on the amount of computation. Now, another thing has happened. From these three scaling laws, we get smarter models.
Why was it important, Jensen, that NVIDIA ends up with almost 3% of Nokia? What was the rationale behind that?
The work that we're doing is so intensive.
And these smarter models need more compute. But when you get smarter models, you get more intelligence. People use it as, if anything happens, I want to be the first one out. The smarter your models are, the more people use it. It's now more grounded. It's able to reason.
And quite frankly, I was so optimistic about it and so excited about it. We wanted to invest in Nokia so that we could be part, of this incredible success that we're creating together. And I got to tell you, that move was pretty genius, wouldn't you say?
Problems it never learned how to solve before because it could do research. Go learn about it, come back, break it down, reason about how to answer your question.
Not for me to comment on. What I'd observe is, a 25% jump in the ADRs. What does that signal to you? I've known to be about speed. Is it that they're giving you a technology that you wouldn't otherwise have, or have you now a way of just moving faster?
There's no way we're going to have NVIDIA's technology and accelerated computing. I mean, the CUDA software stack, all of the capabilities, even the fundamentals of what's in Ariel, the software.
How to solve your problem and go off and solve it. The amount of thinking is making the models more intelligent. The more intelligent it is, the more people use it. Computation is necessary. But here's what happened. This last year, the AI industry turned a corner.
That NVIDIA has built is an accelerator for us. And then it's about speed because now we can innovate much faster. And for us, it's that shift into adding value in software, and like a software company, and really not like a software company, like an application company that's going to use AI and AI models to continue to innovate and move faster.
Meaning that the AI models are now smart enough, they're worthy to pay for it.
This is no longer about speed or coverage. It's about intelligence. Now, the timeline for this transformation is surprisingly fast. Trials are already underway, with early customer tests beginning next year and full commercial deployment expected by 2027. That's less than 2 years from now. And because the system is modular, every existing Nokia base station could potentially be upgraded to handle AI workloads. No new towers. No new network, just a software upgrade. That kind of scalability is unheard of in telecom. And it's exactly the kind of speed the industry needs to break out of its stagnation. But this isn't just about technology, it's also about politics. Jensen Huang made it clear. Technology has become the single most important lever in geopolitics. He said, "It's our national treasure. It's what will make America great again." That statement captures what this alliance truly represents. Not just innovation, but strategy. By aligning with Nokia, an ally in Europe, NVIDIA ensures that America and its partners retain control over the infrastructure that will power AI, defense, and digital economies for the next century. And that's something no single company or nation can afford to ignore. Still, there's another angle that makes this partnership even more powerful. Speed. Nokia's CEO said it bluntly. This deal lets them innovate faster than ever before. Instead of designing chips from scratch, they'll use NVIDIA's accelerated computing to simulate, test, and deploy new network technologies in real time. The collaboration turns Nokia from a hardware manufacturer into a software-first AI company. One capable of delivering updates, models, and AI services as fast as the industry demands them. And while the partnership was announced with technical jargon and quiet confidence, the implications are massive. This is the first step toward a world where every wireless network is an AI network, where 6G isn't just about connection, it's about cognition. Every base station, every antenna, every signal becomes part of a living, thinking infrastructure. That's the true meaning behind NVIDIA and Nokia's alliance. It's not just about 6G. It's about fusing intelligence into the world's communication systems. So while Elon Musk focuses on satellites and global internet coverage, Jensen Huang is doing something more strategic, building the infrastructure that all AI will eventually run on. And this time, he's not doing it alone. Because when NVIDIA's computing meets Nokia's networks, the result isn't just innovation, it's transformation. End. Cinematic outro line. This is the story of NVIDIA and Nokia's powerful AI alliance, and how it could redefine the future of connectivity, technology, and the global balance of power.
That this is the kind of innovation that this industry has needed. Look, this industry has a history. 3G, we were building better voice networks when the internet was getting started. 4G, 5G, we were building data networks behind where the market was. And today, 5G, when you look at it globally, is still only partially deployed. And in order to innovate, you've got to move much faster, and we need to enable our customers to have different and better technology.
And with this partnership, all of us, speaking of speed, it's going to go to Rubin, it's going to go Feynman, and it's going to go on a clip that basically is at the speed of light. And
I've got to ask you to clarify something, Jensen. You showed it $500 billion over what I think illustrated 6 financial quarters, but 20 million Blackwell.
5 financial quarters.
5 financial quarters. Because it seemed to be technically above consensus, right? But you seem to be suggesting that there is near-term actually an acceleration beyond what you were expecting.
All of that is only data center. Today we announced several new platforms. The NVIDIA Drive Hyperion platform, our Arc platform, our Quantum platform.
No networking.
No networking whatsoever. Well, that's data center, so networking, NVIDIA networking for data centers, but not wireless networking, not wireless telecommunications.
Going already, you can see a demo actually at the booth here in GTC. You'll also see customer trials early next year. And then we think in full commercial. Great thing about the partnership with Jensen is I know he'll be pushing me to go faster, and I'll be pushing his team to go faster, and together that means that we can get to market.
It's compatible with AirScale.
Right.
And all of those millions of base stations could be upgraded to 6G and AI.
There's a lot of skepticism on 6G though, right? It's just a simple yes or no question really. Is the 6G timeline accelerated because of this partnership?
I think it is, because what you can actually do now is, exactly to what Jensen said, you can deploy with Arc, and then if something happens or the standard evolves or it'll just be a software model update that we deploy in applications. It's a completely different model than what we're used to back in the days of deploying these complex integrated low-purpose accelerated computing, and that's why we think it's so compelling.
If the standards change, you got to go fix a chip. If the standards change, you're just and I just upgrade the software.
Jensen, you are traveling onwards now to Asia. I don't know what your schedule is for the jet, and I don't know if you and the president will be at the same place at the same time. It is that you're here in Washington, D.C. We're a few blocks from the White House. You called it the AI Super Bowl, others called it that too, but everyone is inferring from this
to do what's right for America, and I'm certain he's going to go do that. The reason why we're here is because technology is now so important in politics and geopolitics. It's important for us to make sure that Washington, D.C. and the policymakers and all of the people who serve our country to make it great as it stands today and where we're going to go, and the companies that matter to us so that we can make America great. And so that was the primary reason. Whenever there's an opportunity to see the president, I always love that. He's incredibly engaging. He's always learning, and he wants to help America win.